Alrighty, so I think I'm just going to do one. This one's going to be an interesting one. This is question 18D in this chapter in your textbook. So this is moving into complex familiar, complex unfamiliar type territory. I think I've mentioned on a previous video, if I'm showing you things that are complex unfamiliar, they are no longer considered complex unfamiliar. They're considered complex familiar. And so like you just have to be considerate about what you're asking of me in terms of doing these videos with these complex unfamiliar questions. Because if these are now complex familiar, what am I going to give you that's going to be complex unfamiliar on your exams? Okay, so just consider that. So I want to say that this is a complex familiar question, but it's really probably moving up to the unfamiliar territory. Okay, so let's have a look at this one. Now we want to pick the inside function. So again, my tip for picking the inside function is probably going to be picking something that's in the innermost brackets. And for me, I think this is going to be this one here. But luckily for us, that's also the same as this one. So it's going to be a little bit easier to figure out. Okay, so let u equal to 2 lots of theta. And so now we can find the derivative of u with respect to theta, and that's going to just be equal to 2. So rearranging this function now, I'm going to get du over 2 is equal to d theta. I might change that to x just so it's a little bit easier to say, but you know what, I'll just leave it just so we can sort of see the point. All right, so let's substitute in those values that we've rearranged now. So the integral from 0 to this angle pi on 8 of sec squared u multiplied by e to the power of tan u multiplied by du over 2. So we can move this a half out the front of that integral, and then we can integrate this. And I know you're probably thinking, oh my gosh, what are you talking about? That looks like the craziest thing ever to integrate. But actually it's not, and I don't have any more x's left, so happy days. So let's move this half out the front here. So I've got a half of the integral from 0 to pi on 8, and I'll just write this. So this looks kind of crazy, but I want to show you something. This is going to be a little bit of a sidetrack here. So let's jump over here to do this. Let's say I wanted to find the derivative of the function e to the power of 2x. Well, we would just use the chain rule, and when we would find the derivative of this, this would be equal to 2 times by e to the power of 2x. So in other words, I've just taken the derivative. Let's write this in a different way, actually. If we say we have e to the power of gx, when we find its derivative, it's going to be the derivative of that function times by e to the power of the original function. So that's if we were to derive. Now, since we're integrating, we're going back the other way. So that stands to reason then, if I'm finding the integral of something that's in this form with respect to x, then it's just going to be equal to e to the power of gx. Now, how is this relevant here? Well, if we find the derivative of tan, let's just say tan x with respect to x, it's equal to sec squared x. So this here is actually the derivative of this function here. So what that means is that all we're going to do is we're just going to, when we integrate it, it's just going to become e to the power of gx. Isn't that nice? Isn't that just like make your day sing, make your heart sing? Because it's not as tricky as you think. So this is going to be e to the power of tan u. Oh, sorry. Let me just fix this. There we go. Didn't need to write that integral sign out the front because by doing that, I had already integrated. And the other thing that you might notice is I'm not putting the plus c, and that's because we have to find the difference with this particular range here. Okay, so let me clear this off and I'll just show you this last little part. So I've popped u back into here because originally the value of u was equal to 2 theta. Okay, so now we can go ahead, we can substitute in and we can work out our equation. So I'm just going to leave this half out the front until the very end. So we're going to have e to the power of tan 2 theta. So 2 theta, 2 times by pi 8 is going to be pi over 4. So that's going to be substituting into our first equation, and then we're going to substitute again. Subtract tan to the power of 0. Running out of a little bit of space here. Okay, so e to the power of 10 pi on 4. 10 pi on 4 is equal to 1. 10 of 0 is equal to 0. So this is going to become just e, which is like, what is it, 2.7 or something? So e to the power of 1. Take away e to the power of 0. Now, e to the power of 0 is just going to be 1. So we are left with e over 2, take away 1/2 for our solution. So there you go. So that's an example of a more complex familiar, maybe moving into the complex unfamiliar territory. I think technically to make this into a complex unfamiliar territory is that you would have to be given some sort of context around this. So you might be asked like a modeling type question, and that would drag it into that unfamiliar territory. But I want you to be confident with the maths going into this. Even though this is a little bit of working, it's still following those same procedures. We're still letting that inside function equal to u. We're finding the derivative with respect to u and substituting u and du back into that function so that we can integrate again with respect to u instead of integrating with respect to x. Alrighty guys, I'm going to leave it there. Have a wonderful day and I will talk to you again soon. Bye guys.